Hello there. Hi. Sunday morning. Sunday morning coming down. I never liked that song very much. I kind of didn't. I only really recently started to like Chris Christopherson. There's a lot of Chris Christopherson songs I never liked very much, performed by other people, but I've been listening to the original performances of them. I like them. I like them more. Me and Bobby McGee never liked the Janis Joplin version, but the Chris Christopherson version, really good. Especially the recording that I found is like, he starts it saying, "Well, if it sounds country, that's what it is. It's a country song," and that is a good way to start. It's a good way to start any song. Sounds country, that's what it is, man. He says "man" in there, I'm pretty sure. Sounds country, that's what it is, man. It's a country song. Really kind of outraged. Like it came moments after someone complained, like, this kind of sounds like country music. He's like, well, it sounds, yeah, it's great. It's great. Anyway, hi. I want to play with pixels some more. So mainly what I decided, I'm pretty sure I decided the thing we did yesterday, while educational and interesting, was really not a good idea. For a couple of reasons that I'll talk about as soon as I find a wallpaper that I like. Hello, Doug. Hello, Frozen Shores. Hello, Yellow Car. I like yellow cars. Always have. When I first played Grand Theft Auto 3, San Andreas? I don't know. One of those games. I don't think I played 2. I don't think I played 3. Maybe I just played Vice City. Anyway, I played a whole lot of that all at once in one stretch, and for whatever reason, got into the habit of only stealing yellow cars. Like that was just, if there was a yellow car, I would steal it. And it started affecting me in real life. Whenever I would see a yellow car, I would be like, hey, there's a yellow car. I should steal it. I never did. I never did steal the yellow car. So, this isn't great, but let's go with this. Yeah, so the thing we did yesterday was very ridiculous. I played with it a little bit later, fixing up some issues, but let's do this again. And doing the round trip to file just to see, and that's I wasn't sure this is a great idea. I just wanted to see if it was possible. And two things happened that make me think that it's not great. So it is possible, and actually I adjusted this since last night, so we actually are round trip. Kyle, how's it going? I adjusted this since last night to actually round trip to a file, so it will go to a file and then come back. Slight annoyance with that, the channel order changes going in and out of PNG. But anyway, here's the thing. So we did it. We had this 128-bit per pixel image. We split it into this weird grid, like split the bytes out, bottom 8 bytes, 8 bytes, 8 bytes, 8 bytes. So even though we only have 32 bits per channel, 32 bits per pixel over here, 8 bits per channel, because we split it into 4, we still have the total 128 bits. And then we can save that to a PNG, because PNG will allow that, and then we can restore it. So that is the thing that is working. It's just a little dumb. And I'll show you why I think it's a little dumb. So I'll show you two things, in fact. I'll give you a 2-for-1 thing deal. So, first, I just wanted to see what would happen if we just stuck these bytes in a file. And remember that it's weird because, when you look at a file, it's just a whole bunch of bytes, and you don't really know what they mean. It's just a bunch of bytes. It's just a bunch of 8-bit values one after another. That's kind of how you think of files. And but we have a specific way that we want to think about those bytes. So for one thing, we want floats that are 32 bits, and we only have 8-bit bytes. So we need to take chunks of 4 chunks of 4 bytes and sort of squish them together and say that's one float. So that's one thing we're doing. And then we also have an understanding that we need 4 of those to represent a pixel, because we have red, green, blue, and alpha. So we really have like 16 byte blocks that we're using, you know, in a file, whatever. Again, it's just bytes. Whatever, we open in a hex editor, we'll just see a bunch of bytes. But then if we looked at them, we're like, okay, well, if we take these 4 and squish them together, that's the red channel. And then if we do the next 4 and the next 4, the next 4, that's green, that's blue, that's alpha, and then all that gives us 1 pixel. And it's just all squished together. There's no like additional information. So if we do that and just write it to a file like that, it's 16 megabytes. And this is math that you should be, I mean, this math makes sense because this is 16 million bytes. And so if we just like said that we had, what would that be? So we have 1 byte times 4 channels. No, sorry, times 4 to make it a 32-bit, you know? So that's just 1 channel times 4 channels times 1024 times, but for the width, and times 1024 for the height. We should get exactly this. So there's no mystery about this number except for Windows being silly and just the way it displays bytes. But if we look here and look at the actual byte value, we see that it's exactly that. Like there's no mystery there. It's a very, very direct connection between those things. Now this is actually pretty funny to look at because I have compression turned on my C drive. It's actually compressing that quite a bit, like pretty impressively. But ignoring that, we wrote out some bytes. The bytes correspond directly to our understanding of what a pixel is. There's no mystery. Width times height times, there's 4 channels, red, green, blue, and alpha, times it takes us 4 bytes to represent a 32-bit value, and that's it. So that's great. It's just big. It's kind of big. It's a lot of pixels. I mean, it's whatever, 1024 squared, 1024 times 1024, whatever, million plus. It's this many, 1,048,000. So that's a lot of pixels. That's cool. But it takes 16 meg to store it. And that's a lot because we don't get any compression. It's just not great. That's enough of a file size. You're going to have a bunch of them, or you're going to be throwing them around, or like having users save them, whatever, that you want to start to think like, how do we not waste so much space? So here's the thing that's insane. And when I first saw this, I didn't believe it was true. But this is basically 16 megabytes of data. In fact, I'll show you one other thing just to prove it, is that if we even in Unity look at that texture, you know, as it was created. Oops. It's going to say 16 megabytes. That's rounding, but basically that's 16 megabytes. So the thing that's just wild is that when we encode that to PNG, because of the PNG compression, this image, this very specific image that we did, this synthetic like UV image, it has no alpha, and it does have alpha, but the alpha is all set to 1. It has no blue, the blue is all set to 0, and there's just a gradient in red and green, and it's all normalized 0 to 1, the red and green. When we make a PNG of that, it is only 81 kilobytes. And when I first saw that, I thought it was broken because that's crazy. But that's just the ping compression doing its job. For example, I think everything down here is literally black. So that is that's a million black pixels, and the PNG is just like, I'm not gonna store a million black pixels. I'm just gonna say, I'll just make a note that the next million pixels are black and we'll be good. I don't need to write it down a million times. And PNG is pretty good at that kind of compression. And so that's great. So when I first saw that, I was like, this is incredible. Like, look at the savings is orders of magnitude. We're orders of magnitude smaller than those bytes. So that's pretty awesome. However, then I was thinking like, well, wait a second. This is extremely synthetic. Like, we're only using 2 of the channels, which maybe is right. You know, we don't really need, we'll probably never use the alpha in this particular case, but still, it's still kind of fake, you know? It's not, we're not really using, this is not a real world scenario. So then I was thinking like, well, what if it was a little more real world? And so what if we did have some random values in at least in the channels that we know we're going to use, even if say the alpha stays 0, which I think is okay. You know, that goes into the uncompressed file, but like if we're gonna think of it, we're gonna compress this no matter what. We're gonna compress it, so it's good. So let's just say there's random values in red, green, and blue, which you would, you know, there's going to be crazy, if this is for storing crazy particle systems, who knows what will be in those values. So this is just some noise, essentially, in those channels. And we feel pretty confident that we're reassembling that noise as you would want. Now you can see we have data all the way through. You know, we've got noisy looking data all the way through our whole, our split channels. And now the size of that is 12 megabytes. So suddenly that 81K, where we were being extremely fake, isn't very realistic. Even if we said like, we'll just, if we stayed normalized in the range of 1 meter to 1 meter, let's see how we do there. Does that actually not even matter? Because it doesn't even matter. And the reason probably is once we have negatives, yeah, it just doesn't matter. Okay, so the point is the value of this PNG breaks down pretty quickly because one, it requires a processing step to output it, and it requires a processing step to bring it in. So you've got to do work to put it out and bring it in. Even if you can do it pretty fast, it's work to do out and in. You've got to like figure out the code and do it, whatever. Even if we did the shader version to be kind of the same thing, you've got to do work to get it in and out. It's also like totally non-standard. So even though if you say like, oh, well, it's a PNG, it can go anywhere. It's like, yeah, kind of, but whatever you do, you have to do processing. So even if you're going to try to use this in 3JS or whatever, you're gonna have to go through and do weird stuff. Like, its usefulness as a ping is kind of gone because it's not really storing pixels in the way ping wants. The ping compression doesn't seem to handle this well. I mean, it's doing the best it can. Here I have noise, of course, so that's not gonna be great. This is maybe a worst case scenario compression wise. And in fact, if I put randomness in that other channel, we probably just would be back to 16 meg. I think all the compression that we're getting here is just because of we have a 0 here, and that if we stuck randomness, which we wouldn't do in this scenario, in this particular storing pixels scenario, but let me just verify that that's right, because then I think we're at that point where it's the the ping compression is going to be like, I can't do anything with this. There's nothing I can do. It's 14, so we save a little bit, but not an incredible amount. And I think it's because the compression, the ping compressor, the ping compression algorithm is like, I don't know what to do with this. This is just a bunch of noise. Like, what am I supposed to do with that? And even if you had something that previously was fairly close, you know, that in this land would have been something that the PNG could compress, like, these are 2 adjacent pixels and they're pretty close, so let me compress that. Because we're splitting them apart, the minor differences that you may have seen here are amplified into something totally different where maybe that the compression is now going to be less efficient. So like, I think that's kind of an assumption, but it looks to be true that we're kind of actively working against the ping compression. So you still might argue that like, okay, well, that's a little better. It's still a little better than this. And to be clear, this takes almost no work. This is all, you know, we do all this stuff to sort of do a little dance to get ready to export that ping, and we do a little dance to import it. The thing just to export that file is this. It's 2 lines. It's basically nothing. So we take the raw texture data. In fact, I'm a little annoyed we even have to do this one step here. convert to array, that there's not a good way to just access this memory directly and write those bytes, because there is a copy here, which is, to me, is not cool. I don't like that, but I couldn't, it wasn't obvious. It was not a totally obvious way without making a copy to just point at those bytes and write those bytes. Maybe there is some way to do that, but it wasn't obvious. So, but here's the thing. So even though you might say this still looks better, and maybe you might say like, we won't be totally random. Maybe we'll still get some compression. Maybe it'll be 9 meg or whatever. But here's the trick with this. With this 16 meg file and just a, I guess, more generalized compression algorithm, not the, I don't know much about how ping compression works actually, but just a like not very smart compression approach. Where are we? Like gzip. Let's see what we get. So if we just gzip that file, which would be very easy to do in real time. It's going to be more than 2 lines, but it'd be pretty easy to do that still. We can compress and decompress as we read the file even. Okay, well, never mind. I thought it was going to be better than that. It's actually the same. It's actually a little worse. So it's almost the same if we do this. If we do this, it's almost the same, but we also save not needing to do, we don't have to do the dance to go in and out. And in fact, I think that's a little bit artificial. So let me do the, because that was still with the alpha channel, which we don't actually use. I think my big reveal was compromised because of that. Let's try again. Okay, so we're back down to 12 meg here. We're still 16 meg here uncompressed, but let's see how we do now with a bunch of zeros or ones for the alpha channel. 12. Okay, that's funny. So I wonder if like essentially that's as good as this compression is, so it's slightly better. So I guess my point is this approach, which doesn't involve any of the crazy ping thing, like doing ping nonsense, is as good or better without doing any of the nonsense. You know, like we don't have to do any of this silly stuff. And we could try different compression. I don't know. You know, say for example, if we did a zip, I don't actually know if that's going to be better or worse or comparable. It's a little bit better than both of those. D-Lobster. So I don't know how much of that you caught, but just compressing, outputting the bytes and compressing the bytes is as good or better than the PNG, and you don't have to do any of the weird stuff. So I'm not sure, even though the PNG stuff works and it's kind of cool, I'm not really sure it's worth it, because I have a pretty fast way to do the other thing. I think this is funny, but once you, and I don't know if you just joined, this is the thing that's crazy though. If you have data that's like very artificial, like if we go back to that UV data where we're just normalized, just normalized 0 to 1, the ping file is insanely small. So that's a question. Do you know what are your ranges kind of arbitrary? You don't know, right? They're just positive and negative something. It's not like between -1 and 1. Yeah, so, but this is insane. Like with this very synthetic data where it's a gradient, you know, where it's something that a PNG would be good at compressing, it's only 81 kilobytes, but it's so artificial. You would never really have this. Wait, sorry, you're doing what for brushes? Oh, to a normalized? But even as soon as you have, but it's negative, right? It's still a range -1 to 1. What do you mean? In this case, the range I'm using is -1 to 1. But it kind of doesn't matter. My point is, with non-totally synthetic data, the PNG is pretty giant. It's just that the crazy 81K thing was just if you just did like, you know, straight UV gradients in those two channels. But even here, you save a meg on just the gzipped bytes. Bad internet, missing stuff. Okay. The summary is the PNG thing works. It would need some work to like wrap it up to make it a useful thing, but I mean, you know, this could be a .cos file. And it would just be a binary file that is smaller than a PNG, potentially. Probably around the same size as a PNG for the same amount of data. But then you don't have to do, you don't have to be fancy. You don't have to do a bunch of, you don't have to do all this stuff. And this stuff is fast. It's certainly fast. I just don't know that there's a huge advantage to doing it. You know? The thing we'd have to do is the streaming gzip decompress, because then you can decompress it while you read it, which is pretty cool. There's still one conversion that I just don't like, but I don't really know how to get around it. I don't know if any of there's these other compression methods. I don't really know if any of them would be better for this specific kind of data. Decompress. This is decompress in a single pass. So there's this other, I mean, I don't know anything about this particular. But if we quickly set up the streaming version of it, we could, do it one of two ways. You could compress it as a memory stream and then write that, but I think it's actually better to just straight up compress it as you write to the file. Like basically this. Let's see. Let's see if we can do this real fast. So it would be something like, where we'll just stub this out first and figure out what we need to actually do. We need a system.compression. Oops. And system.io, I guess. So this would be, why is this called? This would be open. What did I call it? I guess it doesn't matter. Save.cosm. Save.cos. So we would need Compression mode, decompress. I think that's how you do this. I wonder if there's a... So what does a gzip stream want? It just wants a stream of some kind? Yeah, it doesn't care. Leave open, compression mode, compression level, compression mode. Yeah, I think we can just read the whole... Dude. Like, is read async just a single byte, or is it the same? Is it the whole file? Because there's a read byte. Begin read. Read span. If read async. So asynchronous reads a sequence of bytes from the current stream. It advances. Can I read all of them? Kind of weird there's not a read to end. Is there in the base stream? No. Okay, so the underlying stream is a file stream. I thought it had a read all bytes or read end or something. There's just a read. So how can you read everything? I guess we would just want to say because this must be like a start and an offset or something. Do we know how many bytes are in the whole file? That's with the cancellation token. We don't really care about that. So the buffer to write the data into, the offset, and the maximum number of bytes to read. So how can we know the total number of bytes? Maybe we don't? I mean, in this case, we know. We know? Or do we not know? Like, we know how many bytes we think we want, but I guess that's still right. You know, we know it's the 16 million. Because it's 1024 times 1024 times 4 times 4. Right? So if we were able to do read async and we were able to say read into our byte buffer starting at 0 to byte count, I don't know about that. I just don't know. This is the one that we did. Yeah, okay, so this is going to be bytes.cause or save.cause. Right? Like, that sort of seems like a thing that would work, but I don't know. Let's just try it. Certainly could be wrong about the number of bytes. Because I don't know if that's the number of compressed bytes or uncompressed bytes. I assume it's uncompressed because we're inside decompressed land. That didn't explode. Kind of weird that there's not a... There's got to be a way, right? To like read... I thought a file stream could do that actually. Like read to the end of the file. At the same time, if we're uncompressed, we should be uncompressed. That should be what we want, right? Okay, so when we compress, we do basically the opposite. So we'll still have a using file stream file.create no. Might be mad because it already exists. I thought there was like a create or open or whatever. Who knows? Okay. So we do this. This will take in some bytes. This will return some bytes. Okay, so and then inside here we're gonna have another using gzip stream, new gzip stream. Again, we're using the file stream, but this time we want compression mode compress. So now we're compressing, and how do we do this? Like I want to write everything. Also, we should do this, by the way. Excuse me? Oh yeah, sure. This time not threading, not tasks. Yeah. Okay. Maybe. You'll be void to start with. That's fine. We are gonna await you. We still know the byte count. We're gonna write async bytes. Same thing. We're just writing this time. Okay. Whoa, don't go over there. Oh, David can't watch the stream. That's fine. Good thing there were no secrets shown in Slack. Okay, so something like this. Something like this. Process pixels. And I just want to be in async land so we can await stuff here. So where will we actually have pixels worth? Basically here. So if we take this byte array, do a 2 array on it, then we'll compress that. And this is just compressing straight up whatever's in you're not supposed to be. Can this be a task with no type? I guess so. Okay, I don't know what this is gonna do with existing files, so let's just delete this for now. You can go away. Okay, so we wrote. You saw that was a little bit slow. I mean, we both decompressed and compressed, so maybe it shouldn't be too surprising. So there is our COSM file. Do we think we actually... do you think that actually worked? Well, I don't know. I want to play a game. I wish there were any good games out. All games are bad. It's a bad year for games. I mean, I kind of want to play the new Nier, the new old Nier, but I don't want to pay $60 for that. Feels like a thing that's going to come to Game Pass. It just has that feeling. Okay, so we do that load and unload all at once, and that is not super fast. I'll admit it. We should time like the ping saving and stuff too. Anyway, so I wonder what is slow. The compression, perhaps? The gzip? We can try those other compressions. I'm interested to see what they do. We should just delete the existing one first. Okay. Wasn't a huge delay. It was definitely a delay. Not a delay. A few seconds. So we do that. Do we get our COSM file? We have our COSM file. So let's just try to read from that instead of doing this whole thing. So this is the whole thing that is the do the out texture and all that stuff. So this will stop doing that. Okay, so I will say though, you know, just seeing the amount of time that takes, there could be a real advantage. We could decide that the save and load of PNG is something we want because it's snappy. Seems shockingly fast, in fact. This encode to ping, we should time that. That's synchronous too. This is blocking. Okay, so what am I doing? We want to try to load that now. So first we did, let's just take all that stuff. Where are you? Oh. We don't need to do this anymore. That was not helping our speed. So just at the end of this, the end of the rainbow, let's do this stuff. Let's get that byte array again, even. Like, we'll just do... Let's do the whole business. Where are you? In here. All right. Do the whole thing. We'll get the raw texture data. We'll save it to the file. We'll load that file. And then we will try to use it. How? This is the part that I don't actually know how to do. This would be save. This would be load. So what do we do once we have these bytes? We want to make a texture from them, but they're like either we have to create a native array with them, which you assume there's some way to do that. What am I doing? Get out of here. You assume there's some way to do this? Yeah, you can give it bytes and an allocator. I don't know what an allocator is in this context. But you can give it bytes. Interesting. But I think that's not what we want to do. I think we actually want to do a... Is there anything in here that takes data? I don't think there is. I think you basically have to make a dummy texture. And then we need a... I thought there was a load. Also, we want to do this, by the way. What? Load raw texture data. Duraj, how's it going? How's your weekend? Load. I think we want low raw text. Yeah, but how do we do this? We just give it data. Fills texture picture with raw preformatted data. This function fills texture. I can't remember if you told me before. Did you tell me where you live? Where in the world are you? You don't have to tell me if you don't want to. I just want to know what time zone you're in. I know. I streamed yesterday. I won't be able to stream very much during the week for a while. So it looks like we need to already have our texture set up. And then we are just literally going to stick the bytes in there. So that seems fine. That seems almost ideal, in fact. So we could just do this. Because in this case, we know. If we didn't know, it would be kind of a problem. But we know exactly the texture we want, because it's the texture we started with. Same format, same size, etc. And then we can do load raw texture data with those bytes. Is that the right way to do this? That didn't work. It's hard to say why. Our save could be bad. That seems like about the size we would expect, though. So I kind of think our save is okay. Our load could be bad. But our load is just like the inverted version of our save. Or our texture setup could be bad. Oh, we probably have to apply these. I bet. Load texture data, probably. Call apply. Yeah, okay. Maybe that's all it was. I hope that's all it was. It'd be a little annoying to try to vet some of those things. That does not appear to be all it was. How are we gonna debug this? If we, for example, can we do this? We have to rename this to .gz. And then gunzip save.cause.gz. And then this is basically just our binary data. And then we need to open this in a hex editor. My quality bad? You're the only person in like 3 years, almost 4 years of streaming who has complained. Daraj, I'm looking at you. Don't need to alert. I don't think I want to change my quality for one person. I can't anyway. My only options are auto and then the source, 108060. So I can't do anything about it while playing back at least. I can do nothing. There's nothing I can do. I apologize. Okay, so we want... Where's our hex editor? Didn't we get a cool hex editor? Oh. I mean, but I can't do anything about that, right? Can't you just watch at a lower quality? I can't do anything about it. There's nothing I can do while streaming. Kind of forgot I was streaming at 108060. You don't really need to. Probably stream at 108030 and it would be mostly fine. You can't just in the player switch it, select a different quality? The Twitch player doesn't let you just pick the quality? I thought it does. I thought it did. You can't just say quality. No, it really only shows you the source? That's weird. I thought Twitch let you do that. I guess I'm wrong. Quality. Yeah, why? Twitch channel not allowing quality. I don't understand that. Why do some channels do it and some don't? Quality settings only work for partners, some people say. Oh, I might not be important enough. Yeah, so it might be that that Twitch only allows that for partners. I mean, I'm not going to change the quality of that I'm streaming for one person. Twitch does not. So if you can complain to Twitch and tell them that you think they should let you pick the quality for every streamer, but apparently Twitch decides which streams you can choose the quality for. So certain streams get the quality setting and certain streams don't. That's pretty lame. I mean, I guess they don't want to do, you know, heavy video re-encoding for somebody with nobody watching. That's fair. So the only thing we can do is go tell everyone to watch my channel so I become famous so that Twitch will re-encode my videos. This is very good. The Twitch help channel just keeps redirecting to itself. Great. That's a good website. The health portal is broken. Great. No, Duraj, I'm not gonna restart and change my stream quality for one person. No, that's not gonna happen. That is a strangely entitled thing to think that someone would do. It's unfortunate, I agree, that Twitch does not allow quality changes for all streamers, but I'm not going to change my stream quality. I want to stream at 1080-60, so I'm going to stream at 1080-60. That would mean like anybody else who came along would have a worse stream just to placate you. That is a strangely entitled viewpoint. Let's see. So downloads. I thought we got this thing. This thing. So we can at least look. I mean, I don't really know what this is going to do for us, but we can look and try. To look at this. Got a bunch of data in there. Look at all these zeros. 4 channels, 4 channels. Oh, is this still... We're still in the gradient? Or we're doing noise? That's weird. You would think this would be R, G, B, A. But those are all zeros. What are we doing? What are we doing? Okay, we are. Yeah, this is correct. So that looks right. That all of our blue and alpha. So there's data here for sure. So either we're reading it wrong, which is a possibility. So how can we read this? Put a breakpoint and look and see. Are we going to start the debugger? Let's see. Okay, so what is inside bytes? Anything? There looks like there's some values in here. Kind of what we'd expect. We got stuff in the red channel. Stuff in the blue channel. Nothing in green. I'm sorry, stuff in the green channel, nothing in blue, nothing in alpha. And that goes all the way through. So it looks like we're loading our bytes correctly. So is this the problem? The load raw texture data? Maybe we're not using that correctly. So the size of the data and the size of the data in bytes. I mean, you'd think it would figure that out. Oh, maybe size. So we could, alternatively, we could do this instead. Do the get raw texture data and copy into that. Let's do that instead. I mean, that's more how we're doing other stuff anyway. So we would do a the output texture, get raw texture data as bytes. Which returns a native array of bytes. Well, let's call it byte array because it's the byte array. Byte. Okay, so do we have that? I already used this here. That's the float texture data. So we need to somehow copy from, but we need to get so we can go to array here, but how can we go from array? Like a copy from. Okay, can we do this? Float texture data dot copy from bytes. Something like that. Kind of want to just do this. Actually. Maybe that will work. Maybe it will work. I don't actually know. It did not work. Is there anything there, or is it truly black? It's a little hard to tell if it's like pale yellow or black. So, gotta say, I'm a little bit confused. So let's try this. What if I just try to straight up copy the bytes from that we output? So we have like a byte array out dot to array. You would think that I could. Oh, I called the wrong thing. Oh, this maybe was working the whole time. I was applying the wrong texture. Cool. This is supposed to be floated away out. Okay, this may have been working the whole time. Oh well. It did. It worked the whole time. So I just want to add little timestamps around this. Just the exact same thing. Because that actually could be a big advantage of the PNGs, is crazy fast save load. It's worth considering. I mean, maybe we could make some of that other stuff fast. I don't know. Faster. Okay, so the save is what took a little bit of time. Save takes 0.6 seconds, which, you know, on a mobile device could be much. Wait. Oh, did I just name that wrong when I pasted it? Yes. Oh no. Yeah. Load is quite fast. But not really as fast as you'd want, I think. Interesting. What about just the PNG save load? I feel like that was absurdly fast, right? Are we still doing that? Yeah. I could have done that more efficiently, but whatever. Whatever.
I just want to go back.
Okay. So this does the image conversion and it does the writing of the bytes. I feel like it's pretty snappy. Pretty dang snappy. Save PNG took 0 time. Maybe that already happens in the background? No, it couldn't be. Oh, wait. Did we do like a write? Oh, no, we just did a straight up write all bytes. We didn't do anything asynchronous. Oh, but this is still the is this our very fake, very silly PNG? No, it's not. I mean, it's got at least 2 channels of... It's not nothing, right? No, it's a 10 meg PNG. How could that be that fast? Also, why is there nothing... Why does this PNG look blank? Do we make the... Because we said the alpha is 0. So let's do that, and let's do this again, because this just feels a little more realistic. Why is save PNG instant? My save binary took a second. The load was pretty quick. How is that possible? How is that possible? Let's just try not gzip for 1 second. In fact, let's just do this. Are these methods just slow? I mean, maybe all the stream stuff's just slow? It doesn't like it should be that much slower, but maybe it is. Okay, this is a non-compressed. We're not going to compress it. We're just going to save and load. Maybe see how much, if a lot of that overhead is gzip. It is quite a lot. Interesting. So we could try some of those other... I don't know those... Non-cal allocating performant broccoli decompression methods. Decompress in a single pass without using a stream instance. So is it better to use these? Like, is this a smarter thing to do? So we can decompress or try decompress. That would be the bytes. Read-only span. I don't know if we can really use those. I think we can't use this because I don't think we can, unless there's other signatures. Because I don't think we can use spans. Yeah, I don't think we can use this. with the .NET version we have? I don't think so. Whew. Probably next time I stream, I will switch to 1080-30 because there's no real reason for me to do 1080-60. Maybe that will help some problems. So if we made one of these, a broccoli stream. Where's compression level? Optimal. Could also do fastest. So that gzip stream, was there not a constructor that took both the compression level and the... Oh, weird. How do you say if you're decompressing? Or it doesn't? I guess just by passing compression level, you're saying you are compressing, right? Does that seem... That seems not unplausible. It's just implicit. I don't know why you felt like you needed to do this, so you have that booted already. No? Oh, awesome. Cool. Guess we do need that. Okay, I don't know if this is going to be better or not. That's disappointing, though. So far that is a very strong advantage of the PNGs, because they're frickin' quick. Did I do that incorrectly? Oh wait, that'd be the wrong... That was not the place to do that at all. It's up here. Wonder what the Unity compression stuff. Use that instead. That somehow seems slower. Unity engine compression. I know where it was. That was just Unity engine.compression. Maybe it's in here. Fast, normal, best. Maybe that's just wraps. Well, that's a name of texture compression quality. That seems different. Okay, the load is fast. The save is not as fast as I would want. So, and we can't, it seems like we have to use streaming. Maybe we don't. But it kind of seems like we have to. I mean, there's the zip stuff. And there's the broccoli encoder and decoder. There's deflate. So we could try a broccoli stream and just see if these are any different. You know? Can you do something like this in this kind of scope? Like using... I don't think I can do this. Like a type def with a using. I think you have to do that at the beginning of a file. Yeah, like just using. Can I just do that wherever I want? Kind of think I can't. You know? I think I... Definitely looks like I cannot do that. But I want to. No. But I want to make... That's the whole point here. Is I'm trying to make my own dude. Pretty sure I have to do this up here. And then down here I can say anywhere I've got one of these. Oh, I don't know why that didn't work. Cool. Oh no, it worked so poorly. That's weird. Why? Why didn't that work? I don't know. Yank. Paste. Still not quite sold on Vim land, but now I'm in too deep. Okay, so this should be exactly the same. And then we'll try to just switch it to broccoli. The load is pretty fast, and so that's good. But, well, we should try loading the PNG too and see. Because the save is not as important here. So, load. So we just want to try broccoli stream. I know that that's not funny, but I'm going to keep saying it. I can't seem to help myself. Oh. Maybe broccoli is all. Yeah, we can't use it. Sad. So we can only do deflate and gzip. Sad story. That was even slower. And not that different size-wise. Out of curiosity, so initially I was just doing that, like, save your bytes, save those bytes, this thing. So how fast was this? Presumably really dang fast. Where am I? File navigation abilities are not going through right here. So this is just saving a bin file. We're not doing anything fancy to it. We're just saving it. No compression, no whatever. Just out and in. Or not even in, just out. And we could do an in, I guess, and just see. Like, I wonder if all the overhead of the stream stuff is what is really eating our lunch. The bin appears to be basically instantaneous. So we could do a memory stream. And like the compressed bytes. I don't know how to do that exactly. I mean, the read would be easier. Ugh. So I'm trying to, what I'm trying to imagine is, what is there a good way to, how can you know, though? Like, the stream stuff is pretty annoying, which I guess that's the whole advantage of this decoder encoder. You don't have to stream. I don't know if Unity has, I don't think it does, any kind of built-in. Oh man, that would be the handiest thing. Yeah, the Jesus stream. It's just slow, man. I wonder if you could do that, like web request from the file system. Yeah, have you got the content encoding? I don't know. I don't know. Just feels like that stream is slow. Like that is slow. So let's try this. Let's try like this. Just to see, like, right at the bytes, read in the bytes, how fast we can do it. Oh, that didn't work. You know, just, it's basically this. But let's just take compression out of the equation for a second, because I feel like compression is what is causing us grief. If we could figure out a way to cast this all to half, then that would be cool. Like half precision. Okay, so. to this. I guess, I mean, I shouldn't be terribly surprised. It could just be that that stream stuff is real slow. That was real freaking fast. Load bin 0. How can it be that slow? The gzip is that slow. Guess we could try it with a memory stream. I don't really think that would be faster. It's pretty wild, because even when we did it without compression, it still took time. Just the overhead of the stream, presumably, took time. Because all we did was just make a stream to a file. Maybe gzip compress. Memory stream. Yeah. Like, how fast could you do this? Get the bytes instead? I don't know. I don't know if this is... Well, let's leave it synchronous for a second. All right, let's just try. So this is just going to have... I don't actually know why you need the out. Maybe you have to kind of have that to... What are you mad about? What? Let's copy 2. So could I do the exact same thing going the other way? So this would be the decompress. I mean, like, literally exactly the same thing, except this is compress. I guess this lets you avoid needing to do the You don't have to know the size of the gzipped content. You know, could you do this? Compress it and decompress it. I kind of feel like this is going to just make things slower. We've introduced yet another stream here, so I don't know. So if we did compress the spider ray, oh, it's going to be slow again. Well, let's see. And then decompress this spider ray. My heart tells me it's not gonna be fast. What have I done? Do we not copy stream here to a gzip stream? Kind of seems in this case that I actually want to take copy the in stream to the gzip stream. So that's just a decompress, but the compress. So maybe their compress was fine. Yeah, because you can just do this. You can just write here and then close it and then do to an array. So actually we would do, you don't need that secondary one in here. Almost the same. But in this case, that's our outstream. What is the true? Leave open. Why would I want to leave it open? I don't think I want to leave it open. We're gonna do that, we're gonna close it, and then we're gonna return the outstream as an array. I don't know. It seems like we load the file from disk near instantaneously. And so if we can do our decompression quick like in memory, maybe that's good, but I don't know that we can. Well, that seemed pretty freaking fast. Does that actually compress? Is it that much faster to do it this way and not? Wow, really? Maybe I need to go rework some other projects and don't stream two files. Like just load the file into memory as fast as possible and then do stuff on it with the memory stream. How can it be that fast? Unless there's something really weird about the way Unity. I don't see how though. Like if Unity's secretly who knows? Maybe they do something weird to file writes so that they're secretly asynchronous or something. But it's available real dang quick. That was pretty freaking fast. Yeah, that probably means I need to change the way I do some stuff. Okay, anyway, that's fast. It's as fast as a PNG, which is 0 seconds, but who knows what that means, really. I think it's just that the precision of this is very low. So I'm inclined to say that this is the way to do it. Not this way. But you just like basically this and this. Because as long as it's coming in and going out in the same way, I think it kind of doesn't matter. Because then you could have the formats be whatever you want. I think, as long as it's the same going in and out, like you're good. You don't know from the file though. So if you did multiple different, you'd have issues. You wouldn't know. But you know, whatever we say. Save texture data, something. Unless I just want to texture 2D. Right? I didn't really mean to make these static, but whatever. Fine. I can be static, why not? So what that looks like is just this. And as long as your texture is always this, okay, that's something to consider, actually. That is a limitation here. If your format was always the same, you could figure out the dimensions. Because you could get the number of bytes. This would just be kind of all this. Actually, it's a little more in depth to load. Or do we have just extra stuff we don't actually need? So we're going to read all bytes of file name. We're going to make a texture. We don't need this. This is the pretty big assumption. This is the assumption that is big. So in fact, let's do this instead. Like we want to take that texture and we know we want to do stuff to it. Right? So we're not going to return a texture 2D. But we want a reference to a texture. Maybe. And we're going to get the raw texture data. We're going to copy that in. And we're going to apply it. I mean, you kind of could say that it's an in. Because we're not really... I don't know. Can you? I don't know, actually. Okay, so now we could try to do a save texture data with a bytes.cosm. Oh, was I looking at the wrong thing in here? Should have been .bin. Yeah, okay. So we're gonna what? We're gonna save the flow texture in. All right? And then we're gonna create this, but then separately it's a little tricky, like going by the length of the bytes to figure out what's going on, but it's not the worst. Do I have to do this? Do I have to like actually? Guess not. Definitely doing stuff to it. I'm not returning anything. Seems like it works, and it seems really frickin' fast. Seems pretty freaking fast. And, you know, kind of big, but not outrageously big. That really makes me feel like in Cosmic Sugar I could optimize the loads even better. I really kind of think I could. Could I? Oh, let me have it. I'm gonna look on the secret screen over here. Cosmic Sugar. Okay. Because when we load, no, I'm using a memory stream. I forgot. I already changed it because I changed the way load works. So that's already fast, or as fast as it probably can be. Maybe. Maybe. Okay, so I'm kind of into the binary save load. You know? The gzip thing is like a little tricky. That's one thing that is a little bit tricky, because if you wanted to try to make it where you could just drop these in a web browser, that is an issue. Definitely an issue. So you'd maybe want to explicitly say when you're using gzip or not. It'd be freaking cool if they could figure that out themselves, like if browsers could figure it out. Let's see. Like, I just don't know if, can you do this stuff in a browser? LZW. See, here's what's dumb is browsers know how to decode gzip. They already know how. It's just I don't know if you can do it. I think what I just said is true. With the content encoding, actually, like well, it's fun. It's just tricky. Like if somebody drops a file on, how do you know? What can you do about it? Yeah, that would be maybe the one issue here. But it's so freaking fast. It's so fast. I don't know why this remains. Isn't that weird? Kind of a weird thing. Like, how are you still... What are you pointing to? Still weirdly have an instance of preview instead of just preview. Definitely gonna be my fault. It's almost certainly my fault. I think it's pretty good. Here's the caveats are as follows. You really have to be sure that the thing you're outputting is the thing you're inputting. Like, it's all got to be the same. Or the data is going to be wrong. Now, yeah. You could look at the file and know, if you knew that at least it was like, okay, these are 32 bits per channel, so I just know, do the math, figure out what the pixel dimensions are. But I don't know quite how I'd want to incorporate that into this. Because you don't really know until the bytes are loaded. For the flow, that's a little weird. If you wanted to say, like, not use 1024, what would you use instead? 256 times 256, closer to like 90,000, 65,535. But that seems like what you'd probably want. Because if you encoded small and big, I'm just trying to decide, like, how would you know? Based on the file, how would you know? You just look at the file size, or are you like the file name? Or you specifically set a byte, Like, say the first 4 bytes tells you something. Then you've got to be fancier here. I don't know. I don't really know about that. Because say you're on desktop, you got a 1,000,000 particle system, you save that 1,000,000 particle system, right? Now you got this file. That's giant. You could do something really silly like hijack the first pixel. Steal 1 pixel to write file data. And then, I don't know. I don't like that. Adding a little header is probably the right answer. It just makes things a little more annoying. Like when we were in here, you'd like want to write 1 byte. Because you can't, like, the copy to is just, that's all there's to it, right? There's no, oh no, you can have, no, there's no offset. So that's kind of an annoying thing. You know, versus saying like, let's just skip a byte, copy everything else. If I skip 1 byte, like, I just want to know where it starts. Begins at the current position. So actually, I could do this. So we could probably gzip.write, you know, 4 bytes to say how many there are. What are our options here? We can write a byte. We can just write. And then start that offset later. Let's say we do that. So it's a little silly. So like bytes.length. I mean, we can stick whatever we want in there. We could stick the dimensions, the, you know, bits per pixel, things like that. Like we could stick some data in there so that when we came back, we would know. You have to modify your texture that you're reading into, though. Maybe that's fine. Or maybe you just need to give the texture back. But the format, you know, like what do you actually need to know? These 3 pieces of information. You make a little header. Kind of tricky, right? Like, that's all you can really stick in as a byte, or an array of bytes. Yeah, there's this stuff. I really don't want to do that. Not a better way? Oh boy. Lots of marshalling. Pretty lame. Oh, this cool unsafe thing. What I'm just imagining is like you make a little header and then you stick your header at the beginning and then you know how to recreate. You know how to recreate. This layout kind of sequential, so you just know the thing is the. That's kind of a silly way to do this, but this is, at least there's no marshalling. The GC handle version is far better, is it? Why? There's just so much dancing around to make these work. Cool. Kind of like this one. I wonder why it's so low on the list. It's just much less verbose than some of these other dudes. Those seem really complicated just to know how to frickin' look at my bytes. Why can't I look at my bytes? No. All these overinflated. If I could just have a union, it wouldn't matter, right? Right? Can I have a union in C#? You just can't have it, right? Or can I? I mean, that would be cool. Can I do this? I may be barking up the wrong tree anyway. But this would just potentially let me write a little header. Okay, go somewhere where you won't get upset. Where do all of you babies live? Here. So, same position. I mean, these are really in the same place. Okay, that seems cool. We could have a struct of a struct. Okay, here's what I want to know. Like, how'd I do all this stuff? How would I actually want to say this? Field offset. I kind of like this idea. I don't know if that's a good idea, but I just kind of like it. So this is basically a union, I guess. And so I could have all my stuff and then just have a byte array at 0, like bytes of size, whatever, like bytes. So I could have whatever my stuff is, you know, wherever it needs to be. Say it's like the format thing's a little annoying, but I can probably cast that, right? What do you think that thing actually is? Like it's an enum. Can I do that? I wonder. I don't know if you could actually do that. I think somebody was talking about that in here. Here. I mean, we could cast the enum to a something else, right? And they're apparently all the same. Looks like this all fits in an int, right? I think this is pretty weird, but I think that's just kind of cool also. So if I said how would this work? No. Union. Fixed byte. Public fixed byte. Public fixed byte. Bytes. However many? 12? If you got 3 integers. Just stick 16 bytes at the beginning here. I mean, really only need 12. We just do something like this. Is this actually a real life thing that I could actually really do? Unsafe. And do this. Why is everything so complicated when I want to do fun things? So this would have to be unsafe. I don't know. Do I even care about the headers? I don't know. Maybe I'm someone probably don't really have. It's just to know, you know, you kind of want to know something about the file type. I guess if I just write, it's just annoying, right? Because I need bytes. So even if it's an integer, single integer, I gotta get that to bytes. So I gotta have something that's gonna give me, just the bytes. How do I get them? Yeah, I mean, I could do this. I could randomly... Or I could write a little dude here. How do I want to do it? Why did my computer just make a noise when I wasn't even doing anything? Oops. What'd you say to me? You said an async. I mean, all this stuff, whatever. Let's async these up. Is that not real? Can you not async right? Oh, is it right async? Probably right async, right? Yeah. Okay, so that, to make that async, what are you mad about? Both of you would be tasks. like this. That's not where that goes at all. Okay. Same with you. Oh, like that? What's your problem? I don't think that actually matters. It might actually matter. It might not matter. Might matter. Guess we'll find out. Appears to matter. Or I broke something different. What happened? Why not? Where did it go? It's right here. Did I not await so it was like not saved before it loaded? That seems like a thing I probably did. Okay. How about now? I'm surprised let me do it that wrong way. Seemed like it took extra time. Do you think that previously we were doing it wrong? And accidentally like loading it from the previous run or something? And they were just happening on top of each other? Is that actually what was happening? Maybe that's actually what was happening. And it wasn't fast. I was just accidentally loading the old version. No, because I delete the old version. So why is this so much slower now? Oh, I know why. I know why. Well, okay. Maybe some things I know and I don't. Some things I don't know. Before we were awaiting and when we were just letting things happen, time wasn't progressing because we were blocking. It still doesn't quite make sense to me though. Like, how is this actually, how is that working? Was it actually just blocking? And it was saying 0 time because it was blocked? And that's actually the same thing that's going on with, I mean, that wouldn't really make sense here. Unless this is all happening, am I doing this on awake or? Oh. Maybe I've been wrong. Maybe I've been dead wrong and it wasn't fast. It just wasn't fast, maybe. That's not right. Is that not right for a coroutine? Am I missing something? Did I... Oh, is that in system collections? Yes. Yes, it is. So I just wanted to make it wait a second to try. So I don't really understand why our save PNG and load seems like it's pretending to be instantaneous. Okay, what if we did this? How could we do this? How can we do this? Let's make you not async. Is asynchronousness hurting us in Streamland? I don't know. What did we break here? No, you're just right. Are we being as like asynchronousness cursing us? Maybe it's bad though. Maybe we were actually blocking frames in a bad way before. So let's just leave the compress and decompress synchronous for a second, just to see what's going on here. And I know we say there's a task. Does it matter? Uh-oh, what did I break? Well, now we have this out of order problem, right? Like how do we fix that? How was this working before? If we were deleting the file, were we actually deleting the file? I thought we were deleting the file. We delete the file. Okay, everybody be synchronous. But I think that maybe actually blocks the Unity clock from advancing, right? So this is all just it's all just a trick. Has everything I've done for the last hour been a lie? That would be embarrassing, but maybe it's true. What did I do? What's your problem? Okay, none of that stuff's async now. So just everything should block. Everybody should block everybody. Block everybody. How did I break this? What are we doing? We're deleting. is that noise? What's that noise? Domain renewed. Well, that's weird because I thought that wasn't due for a month, but thanks for renewing that a month ahead of time, I guess. Okay. Wait. So now I don't understand what's broken at all. Why would that be different? Unless I truly broke this, but I don't think I did. Copy that to the outstream and return the outstream. Oh, we still have an async here. That's probably the problem. That's probably the problem. So I kind of think everything's a lie. Because I think when I'm blocking, I'm not really, like, the Unity time is not progressing. So instead of using time.time for these timers, should it be like... Is that a method? If I do this, I don't know what's going to happen. Gonna print some insane date. But is this really right? 0.14. That feels more like a thing that could be true. Which it's weird. I guess. Okay, what I'm about to say is just made up. So let me just say the thing that's made up. The thing that's made up is that maybe... Oops. Let me type this and then I'll see. In fact, let's run this and then we'll see what's going on. It could well be that async is actually costing us a lot of time because of the way I've seemed to remember that under the hood, Unity does something a little weird for async, and it might wait an entire frame. So it could be these places that we're using async, we're actually spreading that async way thinner than you'd really need to, or like than you'd really expect to. Okay, yeah, our PNG was definitely taking time. Of course it was. We just weren't timing it properly. So a PNG save takes 0.6 seconds. So it takes time. Our binary save takes about twice that, which is not, that's kind of to be expected. So here's the issue. When I make this a sync, it seems like it actually ends up taking more time total because it's spread across frames, because I think the async happens like whatever the tick is that says like, hey, we're going to do this again. I seem to remember that Unity internally, that still happens per frame. So it can make an asynchronous task take way longer than you think it would. Maybe. That's still pretty quick. This is still pretty quick. And the load is extremely quick. So Like if we were gonna load a PNG. How would we do that? Even if we didn't do anything with it, if we just said, let's get the bytes. And didn't use them. Or actually, whatever, let's use it. Int texture dot load. I think it's load image, and that's where were the bytes. I think that's how you do that. And it's supposed to be smart enough to just do its job. Let's try that and just see what the times are. So of course, the reason PNG said 0 is because it was blocking. It just wasn't blocking for very long. So here's a save PNG for 0.7 seconds. A load PNG is 0.14. So we load faster than the PNG load. When we do it like this, if we don't really care about blocking, like you'd lose a frame, that's a bit of a tricky one. Do you care? Because alternatively, as soon as you have to wait for stuff, I'm just worried that it's getting spread a little thin. I don't know. I do think I'm done streaming for a little while. So I tried the thing I wanted to try. It seems at least now we're comparable with the PNG load. We don't have to jump through all the hoops to make it weird. Our load time was actually slightly lower, it looks like, than a PNG load. So that seems fine. We could just decide to let that be synchronous because it might, time duration wise, actually be faster. You would just block for a frame. Ish, maybe. Whatever. A couple frames even, maybe. It's very fast. It's a fraction of a second, but, you know. So are frames. So depending on what you're drawing, it could take a while. I don't know. But I don't want to think about it anymore right now. So, anyway, David, Kyle, Daraj, thanks for stopping by, saying hello. I don't know when I'll stream again. Not exactly sure. Maybe not until next weekend. We'll see. Okay, bye.